Hey guys, so we're going to finish the remaining questions, which is questions 25 to 34 in this video. Okay, so the previous questions are in different videos, so the ones marked in white is one set of videos, so the ones I've cancelled in white, the ones I've cancelled in red is another set of questions that I've solved. The ones cancelled in blue is another set of questions in another video, so this video is going to be from 25 to 34. So let's solve these questions. So question number 25. Okay. Let's see. Okay. 1 over cos square x 1 minus tan x the whole square. Okay, so we have to integrate this with respect to dx. Okay. Now, like I said before, whenever you see something 1 plus in brackets, this should be your substitution value. Okay, and don't just take it, confirm. Do you have a differential for tan x? What is the differential of tan x? So as per the formula sheet, differential of tan x is secant square x. But do we have a secant square x? No. But what I can see here, if you notice, secant square x is equal to 1 over cos square x. Remember that. Alright? Easy. 1 over cos square x. This should be something you should know by now. Okay? And if you didn't, now you know. Okay? So I can rewrite the question as integral of secant square x divided by 1 minus tan x the whole square dx. So, of course, this will be my t. So 1 minus tan x is equal to t. This becomes 0. Differential of this is minus secant square x dx is equal to dt. So therefore secant square x dx is equal to minus dt. Okay, there we go. Okay, how do we solve this? So we substitute, which is equal to integral of dt over t. We know this. T squared. Again. Sorry, my bad. Now, substitute your values, and this will be integral of t minus 2 dt, which is equal to t minus 1 divided by minus 1 plus c. Right? So now t to the power minus 1 goes down, so it is negative. Now minus 1 comes up, negative 1 over t plus c. Now substitute your t, which is minus 1 over 1 minus tan x plus c. Okay, I hope this is correct. So this is the 25th question. Okay, that's it. Very simple. Okay, I think this was the only tricky part. Other than that, everything is substitutable. Okay, moving on. Next question. Okay. 26. So what do we have for 26? Okay, cosine root of x divided by root of x. Interesting. Okay. Now this is quite simple because you know cosine, you have the integral of cosine of x, but there's no root of x, so t root of x is equal to t. Right, so substitute root of x is equal to t. I would better write this equation as cos x to the power half dx divided by x to the power half. Right, so then you take x to the power half as t. So x to the power half is equal to t. Then what does this become? Half of x raised to the power minus half is equal dx. is equal to dt, which is basically 1 by 2 x to the power of half dx is equal to dt. Okay, so do we have this? So we need to remove this 2, right? So 1 over x to the power half dx is equal to 2 dt. I think that's simple. So we have this to substitute and this to substitute. Okay, so we have integral of cosine of t dt. It's actually 2 dt, 2 comes out, which is equal to, what is the integral of cosine is sine. So 2 sine t plus c, which is equal to 2 sine, substitute your t value, x to the power half, or better in that case, root of x, the same thing, plus c, right? So these. Okay, so let's confirm if that is also correct. Alright, so 2 sine root of x plus c. Simple. Let's go on to the 27th. Okay, root of sine 2x cos 2x dx. Okay, easy. Which is your t? Remember, even if you didn't know, you should already assume that this should be your t, because it's in a square root. And most importantly, if I take cos to sine 2x, I'm gonna get cos 2x something, right? If I differentiate, so my cos 2x is there, the differential value is there to substitute. Okay, so given that, I can say sine 2x is equal to t. Now let's differentiate. Differential of sine x is cosine of x, so cosine of 2x, now chain rule, you have to differentiate this as well, which is times 2 dx is equal to dt. Okay, so basically it's 2 cos 2x dx is equal to dt, right? Now you can take 2 to the other side, which is cos 2x dx is equal to dt over 2. Now you just substitute, you have the values with you, substitute. So this and this and this. Okay, so this is an integral is equal to integral, so this is square root of t, and cos 2x dx is dt over 2, so this is dt. I can take half outside, and this is half of integral t half dt. This is simple, add 1 over there and divide by the sum, so half of, let me make this simpler again, plus 1 divided by half plus 1. Okay, so t raised to the power of 3 by 2 divided by 3 by 2 plus c. Okay, now to bring this on the top, I have to take the inverse, right? So which is equal to half times 2 by 3 times t raised to the power 3 by 2 plus c. You know your 2 cancel, so basically it's 1/3 t raised to the power 3 by 2 plus c. So what is your t value? Just substitute your t value now, which is sine of 2x. 1/3 of sine of 2x, right, to the power 3 by 2 plus c. Correct? So hopefully I am right. Correct. That's correct. Okay, so we're done with 27. All right. Okay. 28. So 28. Question number 28. Cos divided by root of 1 plus sine x. Whenever you see sine and cosine, it's the easiest thing. You just substitute for sine, you get cosine. Okay, right? Now, you might think, okay, should I substitute for cos? But the thing is, you don't have 1 over something dx. Usually you want the function of x times dx on the numerator, right? So this is the f of x, and this is the dx on the numerator. You always want that. So that's why I would take this as equal to t. And remember, it's in a square root 2. So simple. 1 plus sine x is equal to t. Now differentiate differentiate, yes. Differential of sine x is cos x. So cos x dx is equal to dt. So I think this is really easy to substitute. So integral of dt divided by square root of t, right, which is equal to integral of dt divided by excuse me, t raised to the power half, which is equal to integral, and if you want to bring this up, it becomes negative dt. Okay, so let's add 1, which basically makes it so simple, plus 1 minus half plus 1. So t raised to the power half divided by half plus c, which is equal to, and then you take half over there, it inverts, so 2 times t raised to the power half plus c. Okay, so what is this? What is your t value? T is 1 plus sine x, right? So remember this. So which is equal to 2 times 1 plus sine x to the power half plus c, or you can write it as 2 the whole square root 1 plus sine x plus c. Okay, both these answers are correct. So let's see if the answer is correct. So this is question number 28. Yes, it is correct. Okay, 28 is done. I think we should be getting a hang of this. Okay, so 29, very interesting. Okay, cot x log of sine x. Okay, now this is interesting. Which one should you take here is equal to t? Right, because if I took cot x is equal to t, can I differentiate? I would get cosecant squared. Doesn't make sense. I don't have cosecant square. But if I take sine x, remember it was supposed to be log of x, but then you have something in it as sine x, so I would take this as equal to t. Okay, this would be equal to t. Now you might be confused, how would that help? So the way I think is, if I take sine x is equal to t, I need cos x dx. Where am I going to get cos x? From cot. Remember, cot x is equal to cos x over sine x. The same thing for tan. Tan x, which is the inverse, is sine x over cos x. You need to know these two. These are very important identities. Okay, so you can rewrite the equation as cos x divided by sine x log sine x dx. Okay, so like I said, sine x is equal to t. Now differentiate this, you would get cos x dx, which you have here. See, cos x dx is equal to dt. Okay, So let's substitute. So integral, so log of t, because sine x is t. We highlight these, okay. And you have sine x in the denominator, which is t again, and then cos x dx is dt. Right? Correct? Now, interesting. Now we have double substitution. This is interesting. Okay. So what we can do is we can take, this is a log question, and I told you many times this is the easiest thing. When you have log, all you need is 1 over t. If you have something like log of x, remember you need 1 over x. Do we have that? Yeah, we have log of t and we have 1 over t. So it's there. You can do the substitution. Correct? So watch my previous video which covered the questions in red. So 4, 2, 3, 14, 35, and 36. They dealt with questions of log. And it shows you the method as to how to quickly do it. So let's do this. So all you have to do is take log t is equal to t. But only, remember, the condition works if you have log of x and 1 over x. If you have both of these, then and only then take log x is equal to t. Okay, so in this case we have both. So we take log of t is equal to u. Now differential of log is 1 over t, dt is equal to du. So let's substitute integral. So this is a new one, which I will highlight in green. I think that's better. Okay. Which is u divided by, no, sorry. Yeah, u, not divided, because, wait, let me rewrite the equation so it's easier to understand. Log t times 1 over t dt, right? Which is equal to integral of what? So this becomes u, we can substitute, this becomes u, and this becomes du. So this whole thing, right? Du. Now what is the integral? Is u square divided by 2 plus c. Simple. So now substitute backwards, right? So first we substitute for this, which is log of t the whole square divided by 2 plus c. And then we substitute the t value, which is sine of x, which is equal to log of sine x the whole square divided by 2 plus c. Easy, right? That was easy. So let's check our answer. So this is question number 29. Correct. Okay, that's great. Now, so let's remove this, delete, and delete. Okay. So question number 29 is done. Okay, question number 30. Okay, sine x over 1 plus cos x. Okay, dx. Again, simple thing, sine and cosine, interchangeable. Greatest thing. Denominator, you have this, substitute, right? 1 plus cos x. You can't do sine x, is because if you do sine x, you will have 1 plus t, you will have t. So if let's do sine x is equal to t, supposing, and then you need cos x dx is equal to dt. Do you have cos x dx? No. You have 1 over 1 plus cos x dx. You don't have this, right? So it's not a good idea to substitute sine x is equal to t. That's all I'm saying. right? But you can do trial and error as well. See, I just did and said, okay, sine x wasn't right. So what can I do? I can write it as 1 plus cos x is equal to t. So this becomes, sorry, sine x dx is equal to dt. So blue again, sorry, correct? So very simple. And by the way, what is, okay, differential of cos x is minus, my bad, so minus. And so give me a second. Yep, so this is minus, so therefore sine x dx is equal to minus dt, right? So let's do this integral. Okay, now sine x dx is minus dt, so we put the negative sign outside, dt, and this becomes t, which is equal to log of t plus c. Now what is this? Log of, what is t? 1 plus cos x plus c. Done. Okay, so let's confirm. This is, by the way, I forgot the negative sign, my bad. Let's confirm the answer. Yes. Okay, we're right. Simple. Now let's go to the 31st question. 31. Okay. Sine x divided by 1 plus cos x squared. Come on, this is easy. This is the same as the previous one. Okay, just you have a square here. It should be very easy to do. So 1 plus cos x is equal to t. So integral dx. So this is minus sine x dx is equal to dt. So you know what to do. So what do you do? Integral of, so this becomes your dt, and this is negative. Again, I keep doing this. Okay, wait, correct, good. Okay, minus sine x dx is equal, so therefore sine x dx is equal to minus dt. Just making it simple for you. Okay. Then look. Okay. Sine x. Okay. Dx is equal to minus dt. So negative divided by t square. Okay. So how would you integrate this? Bring this to the top first. So this would be minus t integral of t raised to the power minus 2 dt. So let's integrate this. So this would be t raised to the power minus 1 divided by minus 1, right? Because plus 1 divided minus 2 plus 1. Okay. So this is equal, this is equal, equal. Okay. Plus c, which is basically equal to minus t raised to the power plus c, which is basically 1 over minus 1 over t plus c. So what is your t? Forgot to highlight this. This is important. 1 plus cos x, which is equal to minus 1 over 1 plus cos x plus c. Let's confirm. So this is question number 31. Yes, perfect. Okay. Now, okay, 31, 32. Okay, 32 and 33 are one of the most important things I want you to remember. Okay, these are 32. So you have 1 over 1 plus cot x. This is interesting. Whenever you come across this, okay, whenever you come across this such that you have 1 divided 1 plus cot x, or 1 plus tan x, or 1 minus tan x, or 1 minus cot x. So you could have this as 1 over 1 plus, I'm sorry, minus cot x even. Okay, or you come across something like this, 1 over 1 plus tan x, or 1 over 1 minus tan x. Break down the cot and tan in terms of sine and cosine, always in these questions, because if you substitute cot x, right, you need cosecant square x, which you're not going to get in the numerator. Okay, you might say, oh, I can use the square identities, but the thing is, the square identities also come with, so you will get what? You get sine, you will get cot square as well. So that's not going to work in your favor, so don't do that. Okay, so let's solve for this. So just remember, whenever you have these questions, break the break cot and tan in terms of sine and cosine. As simple as that. Okay, so let's integrate this in dx. Okay, so cot basically is equal to cosine over sine. So let's substitute. So this becomes integral 1 over 1 plus cosine over sine. Sorry, x. Okay. Now you need to simplify this. So an easy trick, you can take LCM and do those things, but a simpler way I like to do is, if you want to remove this denominator, multiply the numerator and denominator with sine x, right? So multiply by sine x is multiply by sine x. Okay, so let's do that. So what is sine x times, let's do the numerator first. Okay, which is equal to integral. So what is sine x times 1 is sine x. I think we can all do that. Divided by sine x times 1. Again, sine x plus, now this, now what is cos this times this? The sine and this cancels, right? So you're just left with cos x. Now I want you to go to the previous video and see question number 24 and how we solve that. I told you in those questions, I told a very important property, which is if you have sine x, the sum of sine and cosine at the bottom, you need the difference at the top, right? So if you have a question such that you have in the denominator sine x plus cos x, in the numerator you want the same thing, but it should be its difference. So you want sine x minus cos x. As simple as that. Okay, correct? You just want that. It's really that simple. It's that simple. That's all you need. Okay, and the same thing in a different way, if you had the denominator, so I'll write here again, if you had the denominator as sine x minus cos x, by the way, the order doesn't matter whether cos comes first or sine comes first, right? Because it doesn't matter. If you have the difference, then on the numerator you want cos x plus sine x. As simple as that. Okay, doesn't matter. Doesn't matter the order of sine and cosine. Just remember, you need the sum on the numerator, or you need the sum on one part and the difference on the other part, whether that be the numerator or denominator. As simple as that. Okay, so now given that, okay, if you have sine plus cos x here, what do you need here? You need this to be sine x minus cos x. Correct? So here's what we're going to do. Right? So, okay. You need sine x minus cos x. That's one of the most important things. Okay. Now, how do we do this? Okay. What we do is we just simply add and subtract cos x, right? So we have integral sine x minus cos x, okay, plus cos x, okay, plus cos x divided by, okay, because this goes to 0, okay, divided by sine x plus cos x. Now here's the issue. This can be broken down as the sum of sine x minus cos x divided by sine x plus cos x. But then you're left with this question, plus cos x divided by sine x plus cos x. Okay, now what are you going to do? You can't just add or subtract something over here, correct? So what are you going to do? How are you going to simplify this question, right? So what we're going to do is we're going to add another sine x, okay, and this is important. All right, what we're going to do is, first thing is we're going to go back. So this is the situation that we come across, okay, simple, we come across this situation, so we're going to make this situation not happen. And how are we going to do that? I'm going to show you. We're going to add another sine x. So if you remember this, you need one more sine x, right? You need a plus sine x, correct? This is the missing part. But the thing is, we can't keep adding this, otherwise it'll become an infinite sum. We don't want to do that. So what we do is we go back here and we check something. This is very important, okay? What we do is we add sine x in the beginning itself, but this time when you add sine x, so you do sine x plus sine x, which you know will result in, I'm not going to do that, 2 sine x, right? But then you want to remove it. You either subtract it, but instead of subtracting, you divide by 2. So it's kind of like multiplying and dividing by 2, right? So you remove the 2 by multiplying half, right? Cos x. Now see what we can do. Now we can add and subtract cos. Look what happens. Half of integral of sine x, 2 sine x plus cos x minus cos x. We haven't changed anything. The equation remains the same, right? And this is sine x plus cos x, because this is 0 and this cancels out. Okay, simple. Now what do we do? What do we do? Okay, now we spread them. Okay, we give each cos its sign, right? So we give each cos one sine. So we say integral 1 sine to 1 cos, so sine x plus cos x, okay, plus again sine x minus cos x, the whole divided by sine x plus cos x. Okay, and what we'll do is we'll break it down into 2 parts, one sum and another sum, which is basically the difference. So one sum, one difference, right? So then what do we do here? Then let me move this somewhere else. So these are the questions. Okay, let's move this. Okay, let's keep it there itself and let's do this. Okay, so now let's equate this. How do we do this? Interestingly, let's separate them in terms. So half of integral sine x plus cos x divided by sine x plus cos x. By the way, this is dx. I didn't write the dx here, and I sure as hell didn't write it here. Okay, so dx plus sine x minus cos x divided by sine x plus cos x. Of course, this is the integral dx, correct? Because half needs to multiply it across. Okay, now I think you can all agree with this, right? Now this is interesting. This reduces to 1, So that is good. So we have half of, again, integral dx plus, now this is interesting because like I said, all you have to do in this situation, if you looked at the previous video, which is in the description down below, and we solved for question number 24, I believe, okay, is we took this as the denominator. We took the denominator and equated it to t. So all you have to do is now take sine x plus cos x is equal to t. Differentiate. It changes, right? It swaps. So sine x becomes what? What does sine x becomes? Differential of sine x is cos x. Okay. Just to confirm, cos x. And I know cos x is minus sine x. The whole is dx is equal to dt. Correct? Simple, right? Okay. Interesting. Right? So let's confirm that. So differential of sine is cos, differential of cos is minus sine. Okay. Do we have this in the denominator? Okay. We don't have that, but interestingly, if I take minus outside, so I take minus 1, right? Or just say I multiply the whole equation. I think that's an easier way to understand. If I multiply minus 1 on both sides, right, and I'm allowed to do that, what happens? The signs invert of cos and sine. So I get, what do you get? Sine x. Wait, let me make it simpler so that you don't get confused by what I'm writing. Okay, so you would get minus cos x plus sine x dx is equal to minus dt. Correct? Or this would be, I'm just rearranging, sine x minus cos x dx is equal to minus dt. Right? So now you got your substitution values. As simple as that. Okay, plus, so sine x minus cos x is minus dt, so minus dt, remember this, divided by t. So we have to integrate these two, which is equal to half integral of dx is x, you know that, right? Plus, now the minus comes out, so this is negative integral, so this is log of t. And then you have plus c, right? So now you substitute your t. What was your t value? Sine x plus cos x, which is equal to half of x minus log of sine x plus cos x plus c. Right? Now I don't need to put the brackets there, but let's check our answer if we are right. So yeah, let's simplify this too. Okay, this was a long question. I didn't expect this to be that long, but it's a interesting question and you should be practicing this. I would suggest that you mark this on your practice. So this would be x over 2 minus half of log sine x plus cos x plus c. Because half times c is half of c, which is still a constant, so you don't have to worry about that. Okay, this was a big question. This was a long question. This is a good marking question. Okay, so which question was this again? This was question number 32. So 33. Okay, we're almost there. Okay, so we have 2 more questions, I think. Yes. Okay. Oh, there's question 37 as well. I didn't see that. See. So we have 3 more questions. Okay. Interesting. Okay. 37. Oh, 38 and 39 as well. Okay, sorry. 38 and 39. I didn't see that. Oof, long questions. Okay. So let's do this. So let's delete this. And let's delete this. Now, if you could do this question, if you could do question number 32, 33 shouldn't be hard. But I'll still do it with you guys. So let's do it. So, question number 33. So like we said, we have to break down sine. So the question is 1 divided 1 minus 10x integral dx. Again, like I said, if you saw that, you have tan x, break it down into sine and cosine. So tan x is equal to sine x divided by cos x. So let's substitute. That is equal to integral of 1 over 1 minus sine x over cos x. Okay, once you do that, you want to remove the denominator, so you multiply with cos of x. Right, so multiply the numerator with cos of x and the denominator with cos of x. Right, so what is this? So you've got integral of cos of x divided by cos of x. So this times 1 and this times this, cos gets cancelled. You're left with sine of x. Okay, so now what do you do over here? Just the same step as before, right? You multiply by 2, right? You want cos of x. You want to multiply this by 2. You want to multiply by 2 and divide by 2. Okay? Follow the steps. That's all you have to do, which is equal to half of 2 cos x. Remember, we multiplied and divide, so the equation is technically cos x minus sine x. Right? Now, I have cos x, so I need to subtract and add sine x, right? So which is then equal to half of integral, right, 2 cos x minus sine x plus sine x, right? So we're adding and removing, divided by cos x minus sine x. Then we distribute each of the cos to each of the sines, right? So one cos for one sine, right? So which is equal to half integral cos x minus sine x, right, plus cos x plus sine x. The whole divided by cos x minus sine x dx. Right, so this is dx. Sorry, this is dx as well. This is dx. Okay, this is important. So now we can separate each term. So this divided by this and this divided by this, right? This divided by this and this divided by this. So half times integral cos x minus sine x divided by cos x minus sine x dx plus cos x plus sine x divided by cos x minus sine x dx integral, right? Simple, right? Like I said, why we did that is because we want in such a manner, if this is cos x minus sine x, then the sum should be on the numerator. It should be inverse. The operation should be inverse. Okay, so now for the first half, these both are equal, so we can cancel this and this will be equal to 1, which is equal to half of what? Integral of dx plus, Now I told you, whenever you come in this situation, always equate this to t. So cos x minus sin x is equal to t, correct? Now differentiate this. So differential of cos x, let's check again, is minus sin x. Okay, minus sin x, then what? Differential of sin x is cos x, so minus cos x is equal to dt. Okay, so to remove the negative, 1 minute, forgot the dx, so this whole times dx is equal to dt. Now you can remove negative 1 as a common factor from this, which is minus sin x plus cos x dx is equal to dt. Or you can just multiply by minus 1 on both sides, right? Minus 1 times minus 1. That will help with the situation, okay? And you can do that, and that will result in sin x plus cos x, okay, dx is equal to minus dt. This is what you will get, okay? Now if you multiply by minus 1, remember, if you, instead of taking common, multiply by minus 1, you go directly here, okay? You don't go to the next step. This is just if you take minus as a common factor. If you're going from multiplying by minus 1, you go here directly, so don't get confused, okay? So plus, now we substitute, right? So sin x plus cos x dx we have is dt, we have that, divided by t, right? Integral, and then we integrate. So half of integral of dx is x plus log of t plus c, right? So what is your t value? Cos x minus sin x, which is equal to half of x plus log of cos x minus sin x, just substituting, plus c. Now multiply by half with each of the values, which is x over 2 plus half of log cos x minus sin x. Now c by 2 is the same as c, okay, because they are constants. Constant multiplied by constant is a constant. Okay, got it. So this should be the right answer. So let's check question number 33, right? So x by interesting. Oh yeah, this is negative dt. My bad, it was negative dt. So if this is negative dt, see when I make mistakes, all of this was okay. This will be minus 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 because this was negative dt. See the substitution, I didn't see the negative, my bad. So this is negative. Okay, so this is right. Okay, we are almost there. So question number 34. Okay. Okay, and delete. Okay. So question number 34. Let's solve question number 34. Integral root of tan x divided by sin x cos x. Okay, interesting. Now you might be asking what to substitute. Cos x will give you sin x, so these two won't work. What about tan x? Now usually because it's in a square root, you want to take it, so let's do that. Tan x is equal to t, and what is the differential of tan x? Tan x differential is secant square x, so secant square x dx is equal to dt. We know this, right? The thing is, we don't have secant square x dx. or do we have? Okay, so let's check. Let's just check. Okay, let's check. What you can do is, now I know that secant square x is 1 over cos square x. Okay, but there is cos x and not cos square x. So what I'm going to do is, I'm going to make it cos square x. Okay, so let's do that. So let's change it as root of tan x. Okay, sine x cos x times cos x, right? If I multiply in the denominator, I have to multiply in the numerator, correct? So now I have root of tan x, by the way this is dx, divided by, no, times cos x, divided by sine x times cos square x, right? Simple. Simple, right? So I got my 1 over cos square x, which should give me what I want, okay? So I have root of tan x, correct? Cos x, secant square x, because I'm bringing this to the numerator, by the way, dx. Now I have that, right? But then you're asking, is Edwin, okay, now what do we do with the extra cos, right? There's a cos and a sine. Well, if you look properly, I can bring the cos out, which is cos and sine x over here times root of tan x secant square x dx. Now what is this equal to? If you said tan, you're absolutely right. So tan x, so the sine x cos x, square root of tan x secant square x dx, right? And how do you simplify this? Is integral tan x tan x to the power half. Well, let's not complicate it. Let's stay here because it doesn't matter. As long as I don't want to make this too complicated. Okay, now I have that. So I can do my substitution. So I can say tan x is equal to t, and then secant square x dx is equal to dt, as we did before. I'm just writing it again here. Okay, so let's do this. So integral of t times square root of t dt, right? This is simple. So integral of t times t raised to the power half dt, right? I haven't been putting equal signs. Okay, sorry about that. Equal, equal, all equal, equal. Okay. So you know how to do this, which is integral of t half plus 1, which is t raised to the power 3 by 2 dt. And this will become add 1, which is t raised to the power 5 by 2 divided by 5 by 2 plus c. If you want to bring this up, what do? You write 2 by 5 t raised to the power 5 by 2 plus c, right? So substitute for t. What is t? Tan x, which is equal to 2 by 5 tan x raised to the power 5 by 2 plus c. That's it. As simple as that. So this was question number 34. Hopefully this was correct. It doesn't seem right. Apparently I am mistaken somewhere. So the textbook solution. No. Oh God. Yes. Now I see what the mistake is. Okay, sorry. If you caught me on my mistake before, you're doing well. So we have to restart a bit. See, even I make mistakes. Sheesh. Okay. Sorry. This cos of x, cos of x by sine of x is equal to cot of x. Gotta write it properly, sorry. Okay, cos of x by sine of x is equal to cot of x. My bad. Okay, tan is equal to tan of x is equal to sine of x by cos of x. Okay, so it's basically the inverse. So if it is the inverse, which it is, basically this becomes, so you can simplify this as cot of x root of tan x, correct? And then you have secant square x dx, right? Correct. Now I want to make this in terms of tan, which is simple, because tan x cot x is 1 over tan x. They're inverses of each other, right? So this will be the integral 1 over tan x, okay, root of tan x secant square x dx. Now you do the same substitute. Tan x is c, and then and secant square x dx is equal to dt. The only thing that changes, it's now root of t divided by t, integral dt. Right, so what does this mean? This is integral of t raised to power half divided by t dt, right, which is equal to t raised to power half minus 1 dt, which is equal to integral of t raised to the power minus half dt, right? Now let's do this. So this will be t, so I bring, yep, this will be plus 1. Okay, so plus 1 means half, right, divided by half plus c. Okay, for those who's asking, what does that mean? Plus 1 minus half plus 1. Okay, now, so what is the answer? You just bring this on the top, it becomes the inverse, which is 2 t raised to power half plus c. Now what is your t is? Tan x. Okay, 2 tan x raised to power half plus c. Half can be written as square root of tan x plus c. These both are correct. Okay, different variations of the same format. Okay, so that was question number 34. Now we'll move on to question number 37. 37. Okay. The other questions in between is done in my other video with regards to logs. Okay, logs and exponents. So check out the other ones. So that will be part 1 and part 2. And other trig is in part 3. Okay. Okay. So this is question number 37. My bad. Okay. So if I'm right, check. So 34 is done, 37. Okay. Okay, let's do 37. 37 is interesting. X cubed sine tan inverse x to the power 4 divided by, divided by 1 plus x to the power 8. Okay. Interesting. So how do we solve this? So you're looking at tan inverse x to the power 4 and you're thinking, well, I can use the same thing, you know, like I can see if I put tan inverse x is equal to t, and then I would get x squared. And 4 to the power 2 is, no, 4 times 2 is 8, so easily can do that. You're right, but the first thing is we need to reduce this, because you have the differential of tan inverse x and not tan inverse x to the power 4. You don't have this, you have this. So the right thing you should be doing is substituting x to the power 4 is equal to t. Okay. Now when you did the tan inverse, you were almost right, but we'll come to there where you were right. Okay, so x to the power 4 is t, so this is 4x cubed dx is equal to dt. Do you have x cubed dx? Yeah, x cubed dx. Good. X cubed dx is equal to dt by 4. Okay, so now this is equal to 1 by 4 because that's dt by 4. Integral of sine times tan inverse t, correct, divided by 1 plus t squared, right? Because x to the power 8 is just t squared. So if x to the power 4 is equal to t, and then you square it, t squared is equal to x raised to the power 8. Okay? So this and this. Okay. So, important. Okay. Now, okay. Now you can do the tan inverse thing, right? Because now you have tan inverse t, which is there in the formula sheet. So now what you do is you take the next substitution, tan inverse t is equal to u. So this is a double substitution kind of thing. So tan inverse t is equal to u, and therefore the differential of tan inverse t is 1 by 1 plus t squared dt is equal to du. So which is 1 by 4th integral of sine u du. Right? If you didn't get why it is sine u du, let me just make it simple. So this is sine tan inverse t. I'm sorry, sine, my bad. Sine inverse t times 1 over 1 plus t squared dt. Right? Which is e. Give me a second. Back off. Okay. 1 by 4 integral of, now sine tan inverse t is sine of u times du. Right? So what is the integral of this? This is literally easy. Sine is what? Integral of sine is minus cos. So 1 by 4 minus cos u, right, plus c. As simple as that. Now all you have to do is substitute backwards, right? So 1 minute, I forgot to highlight this. So tan u and this. Good. Okay. Which is equal to minus 1 over 4 cosine of what is u? U is tan inverse t. Tan inverse t. Okay. Plus c. Now you substitute for t, which is equal to minus 1 over 4 cosine tan inverse, what is t right now? X to the power 4 plus c. Simple. Right, so let's confirm question number 37, right? So, yes, correct. Okay, so now question number 38. 38 is an interesting question. I think this is the first time you'll be using another formula apart from what we're used to. Okay, so let's see. Integral of 10x to the power 9 plus 10x 10 to the power x, if I'm not mistaken, log of e 10 dx divided by x raised to the power 10 plus 10 raised to the power x. And this is kind of the same as the exponents I should have done this before, but the previous video, but let's do it here. So 38. So you see there is one power low over here and there is one power high over here. And the good thing is this is in the denominator. Okay, that is great. Now the second part is 10 raised to the power x log e base 10. Now how would you get that? Now if you were to take this as t, let's do that, because it's kind of an exponent kind of question, but still. So x to the power 10 plus 10x to the power x is equal to t. So how do you differentiate? This is easy. So this is 9, sorry, this is 10x to the power 9 plus. Now what is the differential of 10 raised to the power x, right? So let's look over here in the formula sheet. This is very important, right? Let us look in the formula sheet. Okay, let me show you. And we have it here. Sorry, give me a second. Yeah, this is the formula. Okay, so what are they saying? So the differential, let's write that down. The differential of a to the power x divided by log of a is equal to a to the power x. But so in this case a's are 10. A is equal to 10 in our question. So all I have to do is take this to the other side. So d by dx of a to the power x is equal to a to the power x log of a. Okay. Okay. So when I differentiate, so therefore d to the power dx 10x is equal to, just substitute 10 to the power x log base e 10. Right? Simple. Okay, so I got it. So what is it equal to? And all I have to do is substitute this in there, which is 10 to the power x log base e 10 is dx, by the way. Oof, I didn't leave space, I think. Okay, that's better. Okay. The whole times dx is equal to dt. This is important. So, the good thing now is we have a t and we have a dt. Okay? Simple. So, by the way, this is also in brackets. If that makes it easier. Okay, so integral of dt over t. Right, which is very simple, is equal to log of t, which is equal to log of what? X to the power 10 plus 10 raised to the power x plus c. Okay, you're just introduced to a new type of formula, and I've just made some adjustment to the formula, and then we got this and we substituted. Okay, so let's confirm if this is there. So which option is this? This is option number D. So D is the correct answer. Okay, so D is the correct answer. It's an MCQ question. So we're on the last question right now. Question number 39. Delete. Yes. Let's do this as well. Delete. Question number 39. Okay, so how do we solve question number 39, which is integral of dx sine squared x cos squared x. This is interesting. Now the basic trick is, and I'll tell you this very simply, so what you do is you take the integral, and I'll just break it down, 1 over sine square x cos squared x. Whenever you have this situation, the simplest thing you can do right now over here in this situation is what? Okay, is substitute 1 is equal to sine square x plus cos square x. Okay, that's the only way, to be honest, because no matter what you do, you can take these up and make it cosecant, and cosecant square, sine square, it's not going to work. Secant and cosecant square, nothing's going to work. This is your best option. So integral of sine square x plus cos square x divided by the product of sine square x cos square x. Okay, so how do you go from here? Separate them individually. So integral of sine square x divided by sine square x cos square x plus cos, by the way, this is dx, cos square x integral divided by sine square x cos square x dx. Now you can cancel. This is simple, 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 simple. Okay, so 1 over cos square is secant square x dx, integrate plus integral of cosecant square x dx. So do we have the integral of secant square? Yes, which is tan x. Okay, and what is the integral of cosecant square is minus cot x. So we have tan x minus cot x plus c. Is this one of our options over there? It is tan x minus cot x. Okay, that is option B. Right, so should that be the right answer? Yes, it is the right answer. So answer is B. Okay, so we're done with exercise 7.2. We've done with all the questions. It took 4 parts. Now the reason why I took 4 parts is because I explain in detail, right? And sometimes I do make mistakes. I get it. I'm not perfect, but the reason I'm doing these mistakes is because I want to show you what my thinking process is, how I come into conclusions whether what to do and what not to do. In some cases like this, I have to agree myself. I had to look through the solutions and kind of give you the steps to expand it. But even the cases where I have looked at solutions, I've actually expanded on them in terms of the formulas. So that's why I kind of did this on a whim, right? I didn't want to be like perfect and then look at the answer and copy it. I wanted to show you what my thinking process is, how I substitute, how I take the value, substitute, differentiate, step by step. So when I make the mistake, it's because I'm doing this first-handed. I'm not doing this 10-20 times and I'm looking through a sheet. No, I'm actually looking through, I'm doing the answer, and then I look at the answer sheet. And then when I make a mistake, I tell you where I made the mistake. And generally it's a silly mistake, and I know it takes some time, but you also get to see the process as to how I think. So I hope you enjoyed. Like, share, and subscribe. And until then, I'll see you in the next video. Thanks.